Okay, so in this video, we're dealing with graphing inequalities. And an inequality is the opposite of an equality, right? An equality, represented by the equal sign. Now we have inequalities, so not equalities. And there are some pretty common signs, right? We have less than or equal to, greater than or equal to, less than or greater than. And we have other videos getting into the details of how to read these signs, but here I want to point out what it means to say k is less than or equal to -2. And this might seem like an easy problem to solve, but it also has some really, I think, profound implications, right? Because what we're saying here is every number, k, so anything, any number you can think of that's less than or equal to -2. So where do you start? That's the question. If you want to list out every number that's less than or equal to -2, how do you represent that? How do you start? How do you finish? What do you do? The key for me here is that it's less than or equal to. So in one case, k could equal -2. So that's where I would start. We know in one particular instance k does equal this number. Okay, so I'm going to mark a circle at -2. And what this is saying is that, oh, one of the things I could graph on this number line is the number -2, because in one case k could equal -2. Or k can be anything that's less than -2. And that's where I think it gets really fun. How do you start there? -3 is a great start. It's less than -2. But couldn't I also say -4 and -5 and -6 and so forth? Couldn't I go on forever? And the answer is yes. To represent every single number that's less than -2, I draw an arrow to the left starting at -2. And really this is highlighting the fact that, oh, I could include numbers like -2.5. That's also in there. And then I get really close to -2, like -2.00000001. So in fact, it's fun to represent all the numbers that are less than -2 by just drawing a filled-in dot at -2. That means we include -2, and then every number to the left, so every number that's less than it. And that's our answer. So really what we're doing in this case is graphing every number less than or equal to -2. And let's look at some more examples to get a better sense of what's happening. So here, in this case, we want to represent p, so every number that's greater than or equal to 5. And again, I'm just going to say it. Here, this is eating. If you think of it as an alligator, it eats the bigger number, right? It's an alligator. It wants more. So p is bigger than or equal to 5. And I'm going to represent that as 5. So in one case, p equals 5, and in the other cases, p is greater than 5, right? So we can represent every number that's greater than or equal to 5 by drawing a filled-in circle at 5 and then an arrow to the right. If you think about all the numbers that are included here, 6, 7, 8, 9, right? It makes sense. Those are all bigger than 5. And we even include numbers that are not so easy to represent, but are implied that they're included, like 5.00000123. That's in there, right? Every number bigger than 5. And I just think it's so cool that we can represent all those numbers, an infinite amount of numbers, but just drawing a dot and a line. And that's fun. Okay, so anyway, we have, in this case, this is a b. b is greater than -6. So this is saying, oh, I do not want to represent the case where b equals -6. I just want everything that's bigger than -6, not equal to. And that's where things change a little bit. And this is a little bit trickier to think about, right? How do we represent every number bigger than -6? Where do we start? And this is, I think, often a source of confusion. Sometimes it's as if we want to draw a line like really close to -6, like maybe right here, and then go to the right, right? Every number bigger than -6. The problem with that is, how do you guarantee that you included really numbers that are really slightly larger than -6? Something like -5.099999. Remember, if you saw what I was doing there, I started to put -6 something, thinking really close to -6, but of course we want numbers larger than -6, so -5.99999 is really close to -6 and larger. How do we guarantee that's included? Well, what we've come up with is the idea that we can represent this with an open circle. And what I mean, let me undo some of these here. In the past two examples, we drew a circle that was filled in, implying that the number the dot is on, in this case it's on 5, the answer includes the number 5. And if you remember, that's because P could equal 5. Well, now B cannot equal -6. So what we do is we put an open circle there. And that's the big difference. So if you see this sign where we have every number that's bigger than -6, don't include -6, put an open circle. And I try to remember that because I think of an open circle being like a perimeter. People try to get in and include themselves, but they can't. So -6 can't include itself in this open circle. Whereas a closed circle, I know this is kind of a silly analogy, right? Imagine that this is letting everyone in. That's why it's filled in. So in this case, we have a closed circle at 5. It's filled in, so 5 is included. And I don't really encourage ridiculous mnemonics, but you know what? If they work, and this one works for me because I don't have a good memory, how to remember whether to use a closed or open circle, I use a mnemonic, I create this analogy, whatever works for you. Anyway, getting back on track, all we need to do now is draw an arrow to the right, because we want to represent every number, right, that's bigger than -6. So it's an open circle with an arrow coming right off of it to the right. And now we get to the next question, next expression, m is greater than 1. This is saying, give me every number bigger than 1. And again, this is the fun part. I mean, you can't just write this out in a list. 1, 2, 3, 4, 5, and so forth. There's all these fraction numbers to include, and of course, you can't write an infinite sequence of numbers. So our solution is put an open circle at 1, right? Because 1 can't be in here. 1 is not greater than 1. It doesn't work. But 1.00001 is, and every number to the right is. So all we do is draw an arrow going to the right. And I think when you see all these different examples, maybe you can start to see a pattern of what's happening.